Hello, we're going to work together to solve a word problem. When we're solving a word problem, first we want to read and we want to focus on what numbers might make sense as we read. In the first bullet point, we see that a hospital hires 2 patient care assistants to work a total of 60 hours a week. Total is always a key word, and so we see a total of 60 hours. We also see here it's 2 patient care assistants, and so we're going to be working with 2 different employees. The second bullet point, the first employee has 5 years of experience and earns $16.95 an hour. So I'm associating the first employee with this pay rate of $16.95 an hour. The second employee has no experience and makes $15 an hour. So I'm associating the second employee with the 15 an hour. The years of experience seems to justify the changes or the difference in the pay rate, but it does not seem like it's going to come into play as part of the algebra equation. And so that's my thought at this moment, and I'll keep that in my head as I keep reading. Again, the last sentence gives me that the hospital has budgeted $950 to pay both employees, so this is the budgeted amount, which is again a total. So in the first bullet point I had a total, and here again I have a total. Before I can go into my word problem, I really need to know what they're asking, and this will help me decide, is the experience truly extra information? So it asks me how many hours. So that means that I need to figure out the hours. I don't need to figure out the experience. I need to focus on figuring out hours. So I'm going to first off let X be the hours for that first employee because we have 2 employees and we already circled the first employee and their pay rate. And then my Y is going to stand for the hours for the second employee. So if I can figure out both of those, I will have figured out this equation and answered the question. Now I want to try to write equations. And we talked about in our notes that the first equation is focused on the items. And my items here are the hours because that's what I'm splitting between the 2 employees. So if I take the hours assigned to the first employee and I add the hours assigned to the second employee, together they should total 60 hours. And I get that from the first bullet point. Together, they should add up to 60 hours that these 2 employees are to cover. And then we talked about that our second equation should come from the value. And so the value is how much they need to get paid. So for my first employee, each of those hours has a value of $16.95. So I'm going to multiply $16.95 times the X hours that they work, and that would give the value of that work for that first employee, also the cost to the hospital. And then the second employee made a little less per hour, and so the value of each hour of their work is $15, and I'm going to multiply that times the Y hours that they work. Now, with these are both money, $16.95, 15. And so when I think about what is the total value of all of this work, I have to be thinking of money. And so I'm going to be using my second total, the $950, as the value for this equation. Now, even though I have the money symbols in the second equation, and that is very helpful to me in sorting out which numbers to put in which equation, I won't actually type the money symbol into the calculator. There are quite a number of ways to solve this equation, and we have videos in our content guide that would help us solve algebraically. What we're going to do in this video is what we're going to do in class as well, and that is we're going to use the graphing calculator. So I've gone to desmos.com to get my graphing calculator. In my graphing calculator, I click in the box for number 1, and then I use the keypad that shows up to type my first equation. So here we have x plus y equals 60. And then we'll click right below this where the 2 is, and we'll type our second equation. And as I said, we'll type this without the dollar signs. So 16.95x plus 15y equals 950. And all of this shows up on my screen. And so I can see up here at the top, the first equation has a little green circle with a squiggle through it. And so that is the green line on my graph. And the second one is purple, so that is the purple line on my graph. Now, depending on how your graph is set up, you will find that you may not initially see your answer. So I'm zooming here. When I first started, the calculator would have looked more like this, showing me the origin here and not showing me my lines. And then using the zoom out feature here, I can zoom out until I see my lines, and then I can recenter if I would like. Now, the solution, the number of hours that is going to answer a question, is found by finding where these two lines meet. And so visually I can see that they looks like they meet right in here. And when I click close to that, the Desmos calculator is going to show me the exact point. So I see key points on my green line are showing up here as these little gray dots. And when I point to the gray dot, it is showing me 25.641, 34.359. And looking back at my problem, it told me I was to round to the nearest whole number. So the numbers that I would have then are 26 and 34 as the number of hours for these two employees. But I do have to think about which number of hours for which employee. So you'll notice in the Desmos calculator, it has the parentheses around the number, and that is because it's considered an ordered pair. So rounding my numbers to whole numbers, I have 26, 34 as an ordered pair. So from the calculator, 26, 34 is that ordered pair. Ordered pairs always come in alphabetical order, so they list the X and then the Y. And because we took time to define our variables, we know that X is the hours for the first employee, and so that is 26 hours. And we know Y is the hours for the second employee, and so that is the 34 hours. Finally, we can check our work. So we can substitute these values into the equations we wrote. And so I can see that 26 plus 34, do that on my calculator, does indeed equal 60. So that equation works out perfect. I can also do the second equation. So 16.95 times 26 hours plus 15 times 34 hours equals 950, we hope. So this is where I go to my calculator, and so I type in 16.95 times 26 plus 15 times 34. And my calculator actually gives me, as this side of the equation, 950.7. And since we're talking about money, that would be 70 cents. So why is it not exactly 950? Well, it's because of our rounding. As we saw on the graphing calculator, the numbers were not whole numbers, but we were told to round to the nearest whole number. And so doing that, the hospital would go 70 cents over its budgeted amount.